All right, so this video is going to show us how to calculate the relative weight fractions of components in a multi-phase sample. So you'll notice, you might notice that these expressions are from an MSE 585 lecture, and we can get the weight fractions of two components, alpha and beta. So these are the weight fraction of alpha. So alpha is just one of the two phases, and same thing for here. As those are related to these R values for the respective phases, and it's related to the intensity for those respective phases. So both of these are what we call integrated intensity. So area underneath the curve. So if our goal is to find the weight fractions, then we need to find the integrated intensities from our experimental peaks using, here and here. So using our peak fitting software. And so we should be able to do that by this point. And then we need to be able to calculate these R terms. And this was a simplification of the expression if we're looking at this here. So R for a given phase is up here. So you can see that up here. So R is going to be related to the unit cell volume. So at this point you'll want to make sure you know the lattice parameter of your material so you can calculate the volume, but that one should be a pretty straightforward calculation. The structure factor, so we talked about this in the previous video on predicting single phase intensities, so go see that one or see the lectures in 585 if you want to get a refresher on how to calculate structure factor. Same thing in the previous video, you saw where to find the multiplicity factor in the appendices of Cullity, and the same thing with the LP factor and the temperature factor. So those can all be solved from appendices or figures in our textbook. So putting that all together along with the integrated intensity, which we can solve for in our peak fitting software, that allows us to calculate the weight fractions of alpha and beta. So there's a lot going into this expression because R is quite lengthy, but once we've done that, the overall expression is fairly straightforward in terms of this, because if we have only alpha and beta, then we know that C alpha plus C beta has to be equal to 1, right? The weight fractions have to add up to 1. So if there's only two phases, then this should be true here. So, so I won't sort of redo everything that I just did in the last video. So if you want to know where to get these values, see the video on single phase predictions. And otherwise though, the only new factor is the unit cell volume that you see here, but everything else is the same. And then you'll want to calculate these integrated intensities or areas from your peak fitting software.